Welcome to Surds Level 4, one step in a level-by-level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic-by-topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 48 divided by 6. Now to start, we want to see whether we can simplify the square root of 48. And to do this, we need two numbers that multiply to make 48, where 1 is on our list of square numbers. Now 48 can be divided by 4, but it can also be divided by 16. And when we simplify, we want to take the largest number of the two. So we can rewrite 48 as 16 multiplied by 3. And so this means that our numerator, the square root of 48, becomes the square root of 16 times the square root of 3. And that's still all over 6. Now, because the square root of 16 is 4, this becomes 4 root 3 over 6. And to finish simplifying, we notice that the 4 and the 6 on the numerator and the denominator can both be divided by 2. And if we do that, 4 divided by 2 gives us 2 root 3, and 6 divided by 2 is 3. So our final answer to problem 1 is 2 root 3 over 3. In problem 2, we're simplifying the square root of 18 divided by the square root of 8. Again here, what we can do is simplify each surd individually and then try and simplify the fraction. So starting with the square root of 18, this can be written as the square root of 9 times the square root of 2. And importantly, 9 is a square number. So this means that when we square root 9, it becomes 3. So the square root of 18 can be rewritten as 3 root 2. Similarly, if we look at the square root of 8, this can be rewritten as the square root of 4 times the square root of 2. And again, importantly, 4 is a square number, which means that we can square root it, and this becomes 2 root 2. So our fraction, root 18 over root 8, just becomes 3 root 2 over 2 root 2. And we can divide the top and bottom by root 2, or we can cancel those root 2's out, and we're just left with 3 over 2, which can't be simplified any further. So 3 over 2 is our final answer to problem 2. In problem 3, we need to rationalise and simplify 5 over the square root of 7. Now to rationalise means to remove the surd from the denominator. And the way that we can remove the root 7 from the denominator is by multiplying it by itself, by the square root of 7. Because when we multiply a surd by itself, the square root part disappears. Now, because this is a fraction, to keep it equivalent, we need to also multiply the numerator by the square root of 7. So starting with the numerators, 5 multiplied by the square root of 7 gives us 5 root 7. And on the denominator, root 7 times root 7 just gives us 7, because the square root part disappears. Now this can't be simplified any further, because 5 and 7 have no common factors other than 1, and so 5 root 7 over 7 is our final answer to problem 3. In problem 4, we're rationalising and simplifying 20 over 3 root 5. Again here, to rationalise means we need to remove the square root from the denominator. Focusing on the square root of 5, we can remove the square root here by multiplying it by itself, so by the square root of 5. It would also be okay to multiply by 3 root 5, but this just makes things a bit more complicated. Now if we multiply the bottom by root 5, we have to do exactly the same to the numerator to keep the fraction equivalent. And if we do that, and looking at the numerator, 20 times root 5 just gives us 20 root 5. And on our denominator, we have 3 multiplied by root 5 times root 5. And root 5 times root 5 is 5. So we have 3 times 5 on our denominator. Now 3 times 5 is 15. So this becomes 20 root 5 divided by 15. And because 20 and 15 can both be divided by 5, we can simplify this further. So 20 divided by 5 is 4, so our numerator becomes 4 root 5. And 15 divided by 5 is 3. So our final answer to problem 4 is 4 root 5 over 3. In problem 5, we're rationalising and simplifying 2 root 54 plus root 150, all divided by root 8. Now if we wanted to here, we could do what we've done the last couple of problems and rationalise by multiplying the denominator and the numerator both by the square root of 8, and this will be fine to do. But since we've got quite large numbers here, it might be worth trying to simplify the surds first and then rationalise if we need to. So starting with the square root of 54, we can rewrite this as the square root of 9 multiplied by the square root of 6, because 9 times 6 is 54, and importantly 9 is on our list of square numbers. So we can square root it, and the square root of 9 is 3. So this becomes 3 root 6. Moving on to the square root of 150, again we're looking for two numbers that multiply to make 150 where one is a square number. And 25 is a factor of 150, and it goes into 156 times. So the square root of 150 can be rewritten as the square root of 25 times the square root of 6. And the square root of 25 is 5. So this becomes 5 root 6. Finally, looking at the denominator, we have the square root of 8. And 8 can be written as 4 times 2, where 4 is a square number. So the square root of 8 can be written as the square root of 4 times the square root of 2. And the square root of 4 is 2. So this becomes 2 root 2. So substituting these into the original fraction, 2 root 54 becomes 2 times 3 root 6, plus the square root of 150 becomes 5 root 6, and on our denominator, the square root of 8 becomes 2 root 2. Now we can simplify the numerator by multiplying 2 by 3 root 6, and this gives us 6 root 6. We still have a plus 5 root 6 and a 2 root 2 in the denominator. Now focusing again on the numerator, 6 root 6 plus 5 root 6 gives us 11 root 6, because 6 plus 5 is 11. So we have 11 root 6 divided by 2 root 2. And we can't simplify any more here. What we can do is rationalize, and on our denominator we have a square root of 2. So we need to remove that, and so we can multiply the denominator by the square root of 2 and do exactly the same on the numerator. Now looking at the numerators, to multiply those two terms together, we can just multiply together the two surd parts. So we have 11, and then root 6 times root 2 is the same as the square root of 6 times 2, which is 12. On our denominator, we have 2 times, and then the square root of 2 times the square root of 2 just gives us 2. So our denominator becomes 2 times 2, which is 4. On our numerator, we need to check to see whether we can simplify it any further, and whether we can split the 12 up into two numbers where one is a square number. And we can, because 12 can be written as 4 times 3, and 4 is a square number. So this becomes 11 times the square root of 4 times the square root of 3. Now the square root of 4 is 2. So this becomes 11 times 2 root 3, all still divided by 4. Now 11 times 2 is 22. So we have 22 root 3 over 4. And to finish off, 22 and 4 can both be divided by 2. So if we divide the top and bottom of that fraction by 2, we have 11 root 3 over 2. And this is our final answer to problem 5. Now going back to this stage, there is actually a shortcut that we could have taken that some of you might have spotted, and that is to notice that the square root of 6 can be rewritten as the square root of 3 times the square root of 2, and that's useful because we have a root 2 in the denominator, which we can then cancel. So if we rewrite root 6 as root 3 times root 2, and we have a 2 root 2 at the bottom, we can now cancel out the 2 root 2's, and we have 11 root 3 over 2, which is the same as the answer we got a few moments ago.